course. So today we are going to go through chapter 3, which is introduction of hydrocarbon. So basically this slide is actually a complement from your lecture note that consists the important concept of hydrocarbon. So what is hydrocarbon? Hydrocarbon is actually the class of organic chemical compound composed only the element of carbon and hydrogen. So hydrogen is made up of carbon and hydrogen element. Okay, the carbon atom join together to form the framework of the compound, and the hydrogen atom attached to them in many different configurations. Hydrocarbons are the principal constituent of petroleum and natural gas. They also serve as fuel and lubricant, as well as raw material for the production of plastic, fibers, rubber, solvent, explosive, and industrial chemical. Hydrocarbons are further divided into three parts, which are alkane, alkene, and alkyne. So alkane is the first group of hydrocarbon. Alkane can be prepared from unsaturated hydrocarbon from alkyl halide, and it also can be synthesized from carboxylic acid. The first step of producing alkane is from unsaturated hydrocarbon. By adding dihydrogen gas to alkene and alkyne in the presence of finely divided catalysts like platinum, palladium, or nickel to form alkane. This process is called hydrogenation. The second step to produce alkane, the physical method to produce alkane is from alkyl halide. On reduction with zinc and dilute hydrochloric acid, or it can also be produced from Wurtz reaction. From Wurtz reaction, it used for the preparation of higher alkane. For example, the Wurtz reaction shown here show the production of N-butane from the starting materials of bromoethane, which is being synthesized in dry ether to produce N-butane. The third step to produce alkane is from carboxylic acid. Consists of two methods: by elimination of carbon dioxide from carboxylic acid and Kolbe electrolytic method. Physical properties of alkane. They are hydrophobic and dissolve in non-polar or weakly polar solvent. The boiling point of alkane increased by 20 to 30 degrees Celsius, which is additional methylene group. They are less dense than water. For isomeric alkane, the boiling point decreases with bunching due to an overall increase in the surface area. Chemical properties of alkane. Halogenation. Halogen flow free radical mechanism and is an example of chain reaction. Combustion. On heating, in presence of air, they are completely oxidized to carbon dioxide with large amount of heat. So basically, alkane are completely oxidized to produce carbon dioxide with large amount of alkane. Nitration. When an alkane is treated with concentrated nitric acid, the nitroalkane is formed. Sulfonation. On heating with concentrated sulfuric acid, sulfonation takes place, forming alkane sulfonic acid. The third group of hydrocarbon is alkene. Alkene can be prepared from alkyne, from alkyl halide, from vicinal dihalide, and it can also be synthesized from alcohol. The first method to produce alkene is from alkyne. On partial reduction of alkyne with calculated amount of dihydrogen in the presence of linear catalyst. On partial reduction of alkyne, dihydrogen cis geometry is obtained. On partial reduction of alkyne with sodium in liquid ammonia, it will form transalkene. It can be shown here in the below reaction. Alkyne producing cis alkene, alkyne producing transalkene. You can see here it using different type of catalyst and condition. Alkene can be produced from alkyl halide. On heating with alcoholic potash, one molecule of halogen acid is eliminated to form alkene. The above process is called dehydrohalogenation. It is shown here generally in this chemical reaction to produce alkene. For halogen, the rate of reaction is iodine, bromine, and chlorine. For alkyl group, the rate of reaction is third, secondary, and primary. Alkene can also be produced from vicinal dihalide. Dihalide in which two hydrogen atoms are attached to two adjacent carbon atoms are known as vicinal dihalide. Vicinal dihalide goes dehalogenation for the formation of alkene. Alkene can also be produced from alcohol by acidic dehydration. On heating alcohol with concentrated sulfuric acid, this process is known as acidic dehydration of alcohol. You can see here the mechanism, the reaction, the chemical reaction of ethanol in concentrated sulfuric acid, which is being heated to produce ethene, and byproduct consists of water. Alkene physical properties. Basically, alkene physical properties are quite similar to alkane, which is they are hydrophobic and dissolve in nonpolar or weakly polar solvent. The boiling point of alkene increased by 20 to 20 degrees Celsius, which is additional methylene group. They are less dense than water. For isomeric alkene, the boiling point decreases with bunching due to an overall increase in surface area. Chemical properties of alkene. Electrophilic addition of halogen. Addition reaction of HBr to unsymmetrical alkene follow Markovnikov rule. Markovnikov rule states that negative part of the addendum adding molecule get attached to carbon atom which possesses lesser number of hydrogen atoms. This chemical reaction show the production of 1,2-dichloropropane from starting material of propene. The third group of hydrocarbon is alkyne. Alkyne can be prepared from calcium carbide, and it also can be synthesized from vicinal dihalide. The first method of producing alkyne is calcium carbide. First, calcium carbide is prepared by heating white lime with coke, which is being shown in the below reaction. Then the treat calcium carbide, then the production of calcium carbide is then treated with water to produce alkyne. Alkyne can also be prepared from vicinal dihalide. On treating vicinal dihalide with alcoholic potassium hydroxide, dehydrohalogenation occurs. One molecule of hydrogen halide is eliminated to form alkenyl halide, which on treatment with sodamide give alkyne. The reaction below show the production of alkyne. Physical properties of alkyne. It follows the same trend of alkene and alkane. First three members of alkyne are gases, the next eight are liquid, and the higher one are solid. Basically, all alkyne are colorless, except ethyne. All other members of alkyne are odorless. They are weakly polar in nature. They are immiscible with water but soluble in organic solvent like ether, carbon tetrachloride, and benzene. With increase in molar mass, their melting point, boiling point, and density also increase. Chemical properties of alkyne. Addition reaction. Alkyne undergo addition to a type of addition of dihydrogen and addition of halogen. It also underwent addition of hydrogen halide and addition of water. You can see for each type of addition it is being represented by the chemical reaction to make you better understand how the addition of alkyne take place. The next group of hydrocarbon, which is quite important, is benzene. The parent member of the family of aromatic hydrocarbon is benzene. It has hexagonal ring of 6 carbon with 3 bonds at alternate position. It is reson stabilized, and the structure may be represented as given ahead. So benzene basically can be represented in these 3 forms. Benzene can be prepared via decarboxylation of aromatic acid. You can see here benzene is being prepared by by decarboxylation of aromatic acid with sodium hydroxide to produce benzene. Physical properties of benzene. Aromatic hydrocarbons are non-polar molecules and are usually or colorless, liquid, or solid with a characteristic aroma. Aromatic hydrocarbons are immiscible with water but readily miscible with organic solvent. Aromatic compounds also burn with steady flame. Chemical reaction of benzene. Benzene undergoes the following chemical reaction. Nitration. Benzene reacts with concentrated nitric acid and concentrated sulfuric acid at temperature of 323 until 333 Kelvin to produce nitrobenzene. In halogenation, benzene reacts with chlorine to produce chlorobenzene. In sulfonation, benzene reacts with fuming sulfuric acid to produce benzene sulfonic acid, and the byproduct is water. Chemical reaction of benzene. Benzene undergoes Friedel-Crafts alkylation reaction. When Friedel-Crafts alkylation is carried out with CH3Cl, the product obtained is C6H5 and CH3, which is also known as toluene. In case the alkylation is carried out with higher alkyl halide, example propyl chloride, then the electrophile N propyl carbocation, which is a primary carbocation, rearranged to form more stable secondary carbocation, which is isopropyl carbocation, and the main product formed will be isopropyl benzene. You can see here benzene react with CH3Cl to produce toluene, and the byproduct produced is hydrochloric acid. Petroleum. Petroleum is important group of hydrocarbon. It is dark colored oily liquid with offensive odor found at the various depths in many regions below the Earth's surface. It is also called rock oil, mineral oil, or crude oil. It is covered by an atmosphere of a gas mixture known as natural gas. It contains mainly alkane, cycloalkane, aromatic hydrocarbon, sulfur, nitrogen, and oxygen compound. When subjected to fractional distillation, it gives different fraction at different temperature. Another important group of hydrocarbon is LPG, which is an acronym for liquefied petroleum gas. It is a mixture of butane and isobutane with a small amount of propane. A strong foul-smelling substance called ethyl mercaptan is added to LPG cylinder to help in the detection of gas leakage. Another important group of hydrocarbon is CNG, which is an acronym for compressed natural gas. Compressed natural gas consists mainly of methane. It consists of 95% methane, which is a relatively unreactive hydrocarbon and makes it nearly completely combustion possible. Petroleum can be produced artificially using this method. From higher alkane, petrol or gasoline is obtained by cracking or pyrolysis. From coal, petrol can be synthesized by following two processes. The first process is Burgess process. Coal will react with hydrogen at temperature of 450 and to 500 degrees Celsius at pressure of 250, producing mixture of hydrocarbon or crude oil. Another process to produce petrol is that Fischer-Tropsch process, which is carbon reacts with steam at high temperature 100 to 1200 degrees Celsius. It will produce water gas, and then it will be underwent reaction with catalyst with nickel at temperature of 200 degrees Celsius at pressure of 5 to 10 atm, producing mixture of hydrocarbon. Octane number. The quality of petrol is expressed in terms of octane number, which is defined as the percentage of isooctane by volume in a mixture of isooctane and heptane, which has the same anti-knock property as the fuel under test. The octane number is 100 for isooctane, 2 for trimethylpentane. Natural gas has octane number 130. Tel or tetraethyl lead is used as anti-docking compound. Octane number is increased by isomerization, alkylation, or aromatization. Cetane number. Quality of diesel oil is measured in terms of cetane number, which is defined as the percentage of cetane hexadecane by volume in a mixture of cetane a, and a methyl naphthalene, which has the same ignition properties as fuel oil under similar experimental conditions. So we conclude our lecture note regarding the chapter 3, which is introduction to of hydrocarbon. So basically, like I like mentioned in previous initially in the first slide, this slide is actually a compressed slide that consists of all the important concept of chapter 3. So this slide is actually a complement from your lecture note. So to better understanding, you can also go through your lecture note to have a better knowledge and also strengthen your understanding regarding this topic. Many thanks for your time and have a nice day ahead.